Assalamualaikum and hi everyone. My name is Wahida binti Azmin, the main author of this paper. Today, I want to present my research with the title Effects of Rubberized Engineered Cementitious Composite Applications as Retrofitting Material on the Structure of Reinforced Concrete Beam Column Joint Subjected to Cyclic Loading. Here is a list of content that I will elaborate more on after this from the introduction to references. As shown in this figure, according to the previous study on 5 June, the earthquake occurred at the bottom of Mount Kinabalu near the highland town of Kundasan in Ranau, Sabah, Malaysia. So this is a several damaged RC component at Ranau, Sabah. ECC is an exclusive cement mixture with a unique composition of low fiber and different composite height in ductility and can enhance the performance of composite structure including joint. To make ECC made, cement combined with fly ash, sand, superplasticizer, PVA, and water. Besides, an ECC is like ECC, but consists of crown rubber small particle as fine aggregate, and crown rubber is good with toughness and deformability. Problem statement, current issues, a structural failure at the beam column junction is a critical and delicate area that has the potential to destroy a building. Since structural performance, not strength, is the basis for current dynamic loading, designers are forced to strike a balance between structural ductility and strength. Effects of the issues, the rubberized concrete has primarily limited performance, and total failure of the structure can occur from damage to the RC beam column joint. So, to address these issues, increase ductility, decrease brittle failure, and reduce failure of a beam column joint, and then provide a sustainable method for retrofitting beam column joint using RECC. Research question. First, what is crack pattern of RC beam column joint retrofitted with RECC jacketing subjected to lateral cyclic loading? Second, how does the load displacements of RC beam column joint react when retrofitted with the RECC jacketing subjected to lateral cyclic loading? And third, how effective is the applications of RECC jacketing as retrofitting material on the structural performance of RC beam column joint? Hypothesis, the use of RECC jacketing mitigates and controls the development of crack in the beam column joint, leading to better overall structural performance. Second, the RC beam column joint structure was increased when retrofitting with RECC in terms of its high ductility, cracking behavior, deformability, and energy dissipation. And third, RECC having high ductility, equivalent viscous damping, deflection, and energy dissipation can improve the structural performance of the RC beam column joint. Okay, next objective. Objective 1 to determine the crack behavior of beam column joint retrofitted with RECC jacketing subjected to lateral cyclic loading. Objective 2 to evaluate the load versus displacement of beam column joint retrofitted with RECC jacketing subjected to lateral cyclic loading. And objective 3 to analyze the ductility and equivalent viscous damping of beam column joint retrofitted with RECC jacketing. Significance of study. Based on previous study, crown rubber as a sustainable material and new green material. For SDG, this study only focused on SDG 9 and SDG 11 only. For SDG 9, emphasizes the need to build a sustainable industry, innovation, and infrastructure to enable economic growth. And SDG 11 may be goals to create cities and human settlements, inclusive, safe, resilient, and sustainable in efforts to achieve sustainability by the years 2030. Scope of study. The external reinforced beam column joint will be the subject of this study because it is the delicate and important part of the structure that is subjected to cyclic loading. The Vista Perdana soft-story apartment serves as an example of a sample building selection. It has 11 resident level and is close to Penang. So this is an exterior joint as an example of a sample selection. The sample was prepared the beam column joint of dimension 150 mm by 150 mm by 705 mm for beam size, and the column size will be 150 mm by 150 mm by 1550 mm. Two beam column joint samples were designed in accordance to BS 8110. The sample 1 was tested to a cyclic load test up to the maximum load until sample 1 failed at 4.5%. The beam column joint damage for sample was retrofitted with 5% RECC using the RECC jacketing and patching method. Then sample 2 was retested after 28 days of curing. This is the research method of this study. Okay, next, literature review. To support the literature review from the research method, as you can see from this slide, literature review summarized the research gap in the table. In a previous study that I researched, samples were mostly RC and ECC, but the lack of RECC was still limited. With this, there is still a lack of study on the structural behavior of RECC. These are several methods of retrofitting based on previous study. First is strengthening by ferrocement at both sides of the sample. The second is the applications of FRP wrapping, and the third is strengthening by ferrocement jacket. This method I choose as my retrofitting method in my study for sample 2. Next, the flowchart for the research activities is shown in this slide, which indicates the objective of this study. Okay, next, this slide shows the design and detailing of the beam column joint. Alright, I will move on to our ECC proportions for retrofitting. The modified needs design and percentage of crown rubber has been referred to in a previous study by Jeffrey 2023 on RECC that was used as a partial fine aggregate replacement. The table shows the sample material proportions for RECC production with percentage 5% of crown rubber as fine aggregate replacement. Next, an experimental setup for cyclic load test of the beam column joint. The sample of the beam column joint was tested at the UiTM Shah Alam Structure Laboratory. Okay, the procedure repair and retrofitting work of beam column joint start with repairing the crack area using concrete seal until testing after being retrofitted for sample 2 using lateral loading frame actuator system. Okay, this is the RECC proportions that we use for retrofitting. The table shows the comparison of maximum crack width with percentage difference for sample 2. From this table, we can see that the value of crack width before retrofit was higher than after retrofit. Among the results obtained based on the experiment for sample 1 is the cyclic load test, which is stopped as soon as crack appear in the sample and the crack appear at 2.75%. Based on the original data, the test is halted at a load of 3% drift, but the sample was tested until fell up to 4.5%. Based on the hysteresis loop of sample to be for retrofitting with RECC, the crack start at 0.1% drift. This sample was stopped to be tested when the patterns of the hysteresis loop decreased, and the test was halted at a load of 2.5% drift. The crack start at 0.5% drift for sample after retrofitting, so delayed crack propagations happen for this sample. The sample was stopped to tested when the pattern of the hysteresis loop decreased, and the test was halted at a load of 2.5% drift. The table shows the comparison of maximum ductility with percentage difference for sample 2 before and after retrofitted. This comparison indicates that the retrofitting procedure improved the joint ductility performance under cyclic loading, making it more resilient and structurally sound. From this result, we can see that the comparison of equivalent viscous damping value at drift level before and after retrofitting illustrated this improvement. This modification showed that the joint ability to dissipate energy improved after the retrofitting procedure, which is important for improving its seismic performance. Conclusion: the study indicates that using RECC as a retrofit material may cause cracks to form, altering their width and patterns. Second, the load displacement behavior of the retrofitted beam column joint exhibited enhanced energy dissipations and increased resistance to crack initiations and propagation compared to the non-retrofitted beam column joint. And third, the beam column joint strengthened with wire mesh and retrofitted with RECC improved deformation capacity and ductility, indicating enhanced energy dissipation capacity and seismic performance. In order to advance this research, increase the amount of crown rubber by 10% to 20% in order to obtain a more appropriate and accurate percentage. Second, apply RECC for other purposes such as train, rail, or pavement and use different sizes of ground rubber. And third, experiment with different type of fiber in the RECC combinations such as steel or glass fiber to increase specific mechanical properties. Acknowledgement. This slide shows the source of material. This is the list of some reference that I refer to the research. Okay, that's all from me about my research. Thank you.